Hello, my name is Eitan Suez, Technical Marketing Manager at Solo.io. In this lesson, I want to give you an overview of the Kubernetes Gateway API. The Gateway API is rapidly becoming a de facto standard for network traffic management in Kubernetes. It has a sort of well-known portal with documentation and a reference to the specification that I'm sort of displaying right here on the screen, which we'll get back to momentarily. And in this lesson, we'll be exploring the Gateway API at a high level. This is the first in a series of lessons dedicated to the Gateway API, in this lesson we explain the motivation for the creation of the Gateway API and specifically how it differs from its predecessor, the Ingress API. And so if we sort of look around for maybe a place to begin, right, we might go and visit the Kubernetes documentation, and under the concepts section, we'll come across a section that talks about Ingress controllers and the Gateway API specifically. And something jumped at me on this particular page, this sort of very succinct summary description of what the Gateway API is. A family of API kinds that provide dynamic infrastructure provisioning and advanced traffic routing. So it captures three distinct things here: that there are more than one resource, that infrastructure provisioning is in scope, so to speak, and that traffic routing is not scoped to just the Ingress scenario. But nevertheless, Ingress is a predominant part of the API. And so if we imagine briefly an environment, this could be in the cloud or on-prem, where we're running one or more Kubernetes clusters, and we deploy onto those clusters our applications, services, APIs, our workloads. The main problem that we're sort of discussing in this lesson is the problem of exposing these APIs and applications to consumers who are outside of this particular network. So the idea is how do we securely arrange for ingress through a gateway. So you see here a load balancer sort of forwarding traffic to an intelligent layer 7 gateway that can be programmed to route traffic to our backend applications. And so we have to ask ourselves an important question: Why is this a new effort? Why does it exist? Why was effort put into building a new API when we had the Kubernetes Ingress API to begin with? And so that's an important question to ask in order to really understand the sort of value proposition of this new way of expressing traffic routing and provisioning infrastructure and so on. And so we begin by looking at the Ingress API, and let's go back to the Kubernetes docs and look at an example of an Ingress resource, right? This comes with every Kubernetes cluster, a resource by the name of Ingress that, in my mind, if we look at this example right here, succinctly describes we could call this a route, right? So there's a rule, an Ingress rule, that defines that a request coming in with a particular path prefix ends up being routed to a particular backend service. So you even see some of the terminology here, the notion of a backend or a workload, and there are paths, which is part of the, in this case, an HTTP request that we're sort of selecting on. And so we very well could ask ourselves a simple question: is, well, what's wrong with this? In what ways does this fail us? And experience has been sort of the way that we sort of discovered some of the shortcomings of this simple API. So maybe the first thing I'll start with is to point out that unlike the Ingress API, where the Ingress resource is sort of baked in when you get a Kubernetes cluster, the CRDs, the custom resource definitions that are part of the Gateway API, must be applied explicitly. They're not baked in. And so here you see a command, a kubectl apply, that would apply the Gateway API resources from what we call the standard channel. There are two channels, standard and experimental. And if we look at the API resources that are part of the standard channel, we get our first glimpse at some of the resources that are part of the Gateway API, a gateway class, a gateway, and maybe two different types of routes, gRPC route and HTTP route, and then there's something called a reference grant. There is a unique point that we can already infer from this output, is the fact that there is a separation that was not present before. In the Ingress resource, we just have one resource. Here we have predominantly two categories of resources: the gateway and then the multiplicity of routes. And so that's perhaps the first observation we'll sort of expand upon, is the fact that the Gateway API model recognizes that there are different protocols, and route definition should be protocol specific. And so it's a simple extensible model where we have a route per protocol, HTTP routes, gRPC routes, and with the experimental channel you'll also see the definition or proposal of definition of additional routes that are still in alpha stages, UDP route, TCP route, and so on. So that's one thing. And so we should be able to essentially continue down the road and sort of itemize the ways in which the Gateway API improves upon Ingress, and that will give us a sense for why it was created. So we'll look at 4 categories: configuration, extensibility and portability, gateway provisioning, and why that's a big deal, and addressing other patterns of traffic other than ingress, service meshes, and egress, for example, are another aspect. And so let's begin with configuration, right? So we think of the Ingress API. It provides a way to specify ingress. But we sort of learn through experience that by itself that is not sufficient. And what I mean by that is we must understand the job of the individuals, sort of the personas involved in configuring the variety of things that are to be configured, in order to properly develop an API that sort of fits in the real world. And so if one sort of an example that sort of illustrates really the problem at hand is the Kubernetes Storage API. And we can go and look at the docs for it. Here we see a variety of different, or at least references to different sections or resources that are part of the storage API. I personally like sort of this illustration, which I sort of came across, which defines 2 categories of resources. That PV there is a persistent volume, and a PVC is a volume claim. But the point that I'm trying to make here is the fact that there are 2 personas. There's an administrator who typically exposes volumes, right, some unit of storage that can then be consumed by a user who makes a volume claim, a claim against that volume, a certain dedicated amount of storage that they want to sort of use for their application to consume. And that's the idea here. So with the Gateway API, here we see again the sort of illustration from the portal on the front page of the Gateway API site, which also makes clear this mapping between personas and resources and how that's really important, and allows also permissioning to be sort of figured out. The fact that infrastructure providers can edit gateway classes and no one else should have any business in there, right? Those are the implementers of the API that give you different options to choose from. The cluster operators who configure gateways, who are really concerned with how do I expose securely specific services to the outside world, and what protocols do I want to allow, what ports do I want to open. And then other categories of users, application developers, who really want to self-service the creation of routes against gateways. And so here you see a distinct separation, and that I would say is the predominant characteristic of the Gateway API that, at least from the point of view of the model, stands out in comparison to Ingress. All right, let's talk about extensibility, because this is really a lesson learned from experience. What we discovered with the Ingress API is that many implementations had a variety of features that they wanted to expose through as a means of configuring by users, where the API sort of came up short, or did not. That was not a concern for the API. And so they resorted to using annotations as a means of defining these additional ways of configuring these gateways. And so if we look, for example, at a couple of implementations, and I just picked a couple at random, the Nginx, Ingress Controller, and Contour, we actually see here an extremely long list of options, perhaps because this is a feature-rich product that has a lot of different options, but imagine essentially specifying all of the sort of Ingress characteristics that you need through a long list of annotations. This is no longer a spec, no longer a standard. And the same thing with Contour. If we look at the documentation from Contour, we could see a variety of different Ingress annotations that are defined here for configuring other aspects of how traffic routing should be handled in those cases such as retries or what have you. So this really defeats portability. I mean, if you imagine an organization that is attempting to that is adopted some implementation and they want to switch to another one, they pretty much have to rework their configurations. So the Gateway API, on the other hand, is really designed for extensibility. It obviously, the anti-pattern was resorting to annotations, so we're not going to do that anymore. And they define a pattern called policy attachments. And that's advice for how implementers ought to extend the Gateway API. The recognition that we're not going to address every aspect that implementations sort of bring with them. We know that there are a lot of API gateways with a myriad of features. And so there has to be a sort of coherent means of extending the base API. And so we can look at an example from the kgateway project. Now, kgateway is both an old and new thing. It's an implementation of the Gateway API that is a donation to the Cloud Native Computing Foundation of the Glue Gateway project, open source project, which has been around for I want to say 7 years perhaps. So a very mature Envoy-based sort of a gateway and control plane for a gateway. And here you see an example from the docs that this resource, I think, its name is going to change going forward to more closely align with the advice given by the Gateway API. But here we see essentially the notion that an implementer can define their own custom resource definition that is a natural extension of an HTTP route or a gateway, or that attaches or associates to a route, and in one way or another provides the ability to define some additional configuration. In this case, it's how maybe header manipulation is going to be performed, which may just be a simplistic example. I think illustrated is probably a little more easier or clearer way of illustrating what the issue is here. If you have a sort of a base API tree or a model tree, you can define additional policies. By you, I mean implementers can define a variety of different policies that naturally extend this API. So we're adding smaller branches or leaves on the tree, so to speak, that naturally extend the capabilities that the core API provides. So maybe there's a rate limit policy or an authorization policy that is not part of the core API, that are custom resources brought by a particular implementation. All right, so on to the next topic, gateway provisioning. The Ingress API didn't really tackle this problem, right? If you, when you installed a particular implementation, the Nginx Ingress controller or contour, maybe you already got a gateway as part. Maybe it was coupled with the installation of the control plane, and there was no specific way, or maybe there was, but not a way that would be the same across implementations to define additional gateways. And so there was a lot of friction in terms of how do you exactly provision an additional gateway if you need, for example, an app to have a higher degree of isolation. On the other hand, the Gateway API, it makes this an explicit part of the spec. The idea is that when you define a gateway resource and apply it to your Kubernetes cluster, this automatically triggers the provisioning of the infrastructure that's necessary to support that gateway. So a gateway deployment, in the case of kgateway, would be an Envoy proxy, for example. And this is a simple and familiar mechanism. So, if you think, we've all sort of defined, for example, load balancer type services in our Kubernetes clusters, and that triggers a Cloud Controller Manager to go out to the cloud infrastructure and provision a load balancer. It happens sort of transparently. And so it's the same sort of idea. So it's familiar, and it really solves the problem of, okay, I need an extra gateway for this particular application team, and that's pretty easy to implement. So let's talk about service mesh and how they factor into the Gateway API. There's a couple of ways in which I want to discuss service meshes. So if we look at some implementations of service mesh, whether it's Istio or something else, what's interesting is that historically they did not just, even though they implemented the Ingress resource, they also provided their own API. So Istio provided gateway and virtual service resources. And that was sort of the beginning of sort of a lessons learned from Ingress, where the community sort of got together to create the Gateway API and brought this idea of splitting the Ingress resource essentially into two separate resources. And so we see, in a sense, the inheritance hierarchy of how maybe these ideas made their way into the Gateway API. Now we have a gateway and a route, for example. The other thing I want to say about service meshes is that the mesh model is now becoming, in a sense, standardized. I mean, there are many mesh capabilities that are not covered by the Gateway API, but those that are allow for the standardization and perhaps improvement of things. So one example I like to point out is how Istio has the concept of subsets, which is part of a destination rule resource. And with the Gateway API, that sort of goes away because we recognize that essentially a subset is nothing more than just a more specific service definition. It can be sort of defined using the service resource. So the sort of initiative to address service mesh use cases is something that's sometimes referred to as the Gamma Initiative. It's an acronym for Gateway API for Mesh Management Administration. That's not too important, but the idea is that the scope of the API is really to go beyond just Ingress, to realize that there's all kinds of traffic management use cases, and they're not all Ingress. There's also internal traffic, especially when you're working with microservice architectures. And this enables all kinds of capabilities, whether it's securing traffic in the mesh or that's internal to or having workload identity, or the idea of supporting canary or blue-green deployments inside your cluster is enabled through service mesh patterns. And so some of those ought to be folded into some kind of standard. And that's the basic idea behind this effort or initiative. So that's a lot of ground we've covered. We are beginning to see the Gateway API really fulfilling a promise to become a standard that's agreed upon by multiple implementers. So if we visit, for example, the implementations page, we'll see a litany of players in the field with implementations that are complying or conforming to the Gateway API. Many of these are GA, generally available. And the service mesh component is being implemented by obviously the service mesh products, whether it's Linkerd or Istio or what have you. And furthermore, it's important to point out that there are sort of spillover effects where maybe other projects that have nothing to do with implementing the Gateway API are now becoming compatible with the Gateway API. So for example, Argo rollouts and Flagger are progressive delivery systems on Kubernetes, which now work with the Gateway API. Or Cert Manager maybe there are ways to trigger a certificate issuer when a new route is created for a particular host name, for example. All right, so in summary, what I want to leave you with is really these 4 bullet points. The fact that the Gateway API improves on the Ingress API in these 4 ways. Role-based configurations, which is very important. On-demand gateway provisioning, which solves a whole category of problems. Support for multiple protocols. And the extensibility problem that we had with the Ingress API sort of is minimized and it improves the portability story. All right, so that's the end of our first lesson. In the next lesson, we sort of flip the page and start looking at getting hands-on with the Gateway API. We'll dive into a Kubernetes cluster and we'll demonstrate basic usage of the API through a concrete example. Thank you for your time, and we'll see you in the next lesson.